Okay, next on the bench, gonna replace some bleeders in this skinny boy, and we're going to be looking at putting in a filament choke, because it doesn't have one, and it should have one. So we're going to do that, and hopefully that'll cure what ails her. We'll be back. Okay. Well, let's get ready to rumble. So, if you're messing around with bleeder resistors, always short each cap out individually. One of the bleeders don't have a good contact, it could leave the capacitor charged, and you won't be having a good day at that point. Okay, we are discharged. You know, I've kind of suspected that this might be a counterfeit skinny boy, or one that somebody really friggin' tweaked with. Okay, so these caps, 450 volt 320F. All these caps are matching. Okay. You can see this here wasn't even soldered. All right. Let's switch tips out. See anything wrong with this picture? There's nothing going to that. So you have these resistors, I don't even know the value of them, just shorting across the capacitor, but there's nothing hooked to that capacitor. That's not how it's supposed to be. So I would assume Skinny Boy knows what he's doing and wouldn't do that. So you're supposed to go, so here's positive, so positive, and there's your negative, and then from negative to positive, negative to positive, negative to positive, and it's supposed to go around over to here. I mean, these capacitors are doing nothing. You know, I just thought I was going to just swap out a couple resistors and, you know, the world would be a happy place. But no. Why in the hell? This is just being used as a standoff at this point. So it's supposed to go So that's negative to positive. Then this negative is supposed to go to this positive. This negative is supposed to go to here. And so on and so on and so on. This is not correct. Well, there's enough solder on this to actually melt the plastic and short to ground. Wow. I'm gonna have to redo this whole damn thing. There is no schematic on it. I'm going to assume this is a glitch resistor. They also call it a fused resistor. I'm going to assume that's a really low ohms. Can't really make it out, but I'm going to assume that's really low ohm. And its purpose is to open up if there's a short. Wow, man. This just got a whole lot scarier. Yeah. I'm gonna redo all that. That's, look at that. That's not right. I gotta clean that up. Wire these caps the correct way. The way we got it right now. So we're only using 6 capacitors instead of 8. Our voltage is, so 450, and 450 is 900, and then, you know, we just add the rest of them, and that's what our total voltage will be. Yeah, literally it's nothing hooked to the negative side there or the positive side there. It's just strapping around and going up. So you do have 6 capacitors in the bank that are active with 2 unhooked. Yeah. I'm going to take a pause for the cause. I'm going to rebuild this capacitance bank. And yeah, take it from there. Okay, that bleeder there was not soldered. Look at that mess. So basically, if you do the math, and I did the math, 6 of them is going to give us 2,700 volts, a 2,700 volt rating on the capacitance bank. Well, I think that's enough. Yeah, it should be enough. So we're gonna go ahead and run with that. Yeah. since this wasn't even soldered on there, and there's really no point for any of this shit. Technically, let's clean up this mess down here. But somebody subscribed to the theory that if a little solder is good, a lot of solder is better. Yeah. Whoever soldered this, wow. Even on a bad day, I could do better. Boy, in shit-faced trunk, I could do better. Okay, what we're looking for, any sign that they melted that plastic. You definitely do not want that to sit right on that plastic like that. Kinda don't need that much solder. Just push it down on there. There we go. Okay, so now we're not touching that. Except for right there. There we go. technically we don't even need that going down there. So let's redo it. The negative side of the capacitor is not hooked to anything. Well, one of them had a resistor hooked to it, but I mean literally it wasn't doing nothing. So we just need to short these cappies out. Right here at this point. You can see that rubber, insulation, plastic, whatever the hell it is. This is rubber. It's actually melted right there. That's what you don't want. You don't want that. Get off of there. This has some really piss poor soldering. I'm sorry, but whoever did this, shame on you. Yeah, see, they melted that. Give it a place to arc. Yeah, I'll have to go through all of these and check that and make sure. This is why I usually pause the camera. They'll be like, we're just going to do this simple little thing. You get in here and start checking it out. It's all cluster fucked. Then I have to get in here. Waste all this extra time to uncluster fuck it. Yeah, you definitely didn't want that smashed down on there like that. a no-no. There's another one smashed down in there, and that rubber is definitely scorched. This is high voltage, so you don't want to take the chance of having stuff short out. Good enough. That's good enough. Good enough. Ooh, there's a clusterfuck. We have to put that back. That was there now. Apparently whoever soldered this did not believe in trimming the excess wires. Well, it's better than it was, so that should mean it's safer than it was. So, right on. Alright. Yeah, we're gonna run with that. We'll have to variac test it and whatnot, but now we're gonna flip it over and see about doing the filament choke. So that keeps the RF from bleeding back into the filament transformer. So we got one to put in there that should work. So we'll be back. So, you know, it just hit me. You know, more than one person was asking why there was no filament choke. Well, it doesn't need one. This is cathode driven. Yeah. So you don't need a filament choke. However, okay, so here's a filament transformer. So it has 3 outputs. So one's the center tap. Pins 3 and 7 are your heaters. Okay, so pin 3 and 7, they're getting 6.3 volts. Alrighty. So there's pin 3. And it's getting fed AC current because you don't need DC. However, 4, 5, 6. Yep, that's pin 7 right there. It's got a capacitor going to it. Yeah. That ain't right. I don't think this tube would have been lighting up. I don't see how it could have. We got pin 3 has AC 6.3 AC volts going to it. Pin 7, nada. Unless they ran that to ground, which it looks like they may have done. Let's test it and see if this is running to ground. I hate it when there's no schematic and you gotta trace this stuff out. Try to figure out what somebody else was thinking. Okay, so yeah, we're good. Yeah, we're going to ground here. So that's fine. Yippers. Another little solder ball. Found a few of those. Okay. Well, so much for that. We do not need a filament choke after all. So I guess tomorrow we will go ahead, put this on the variac, slowly bring up the voltage, and see if everything holds up, and then run a power test. That's it for today. That's Psychotech Labs. Alright everyone, do you know what time it is? It's Mr. Variac time. Now the star of the show, Mr. Variac. Okay, so here we go. All the switches are up. Everything's plugged in. Variac's on. Bring her up, see what happens. So we redid that capacitance bank because it wasn't done right. And actually it was kind of dangerous. So far so good. 75-volt output on the Variac. I need 100, 115. Actually, 120 right there. Okay. So there we have it. 120 volts. And we had high voltage according to the meter. So let's get the Variac out of line. Plug this in direct. We're going to shut this heater off. All right. Let's let it warm up. Okay, so this is a super low drive linear. So we're just going to run the barefoot radio into it for right now. Let's get some meter action going. So that dosimeter back there, it's actually made for like FM broadcast stations. So it shows reverse modulation, severe reverse modulation. So it's actually tied into the dummy load. So yeah, it's line section. Oh, it's warming up. Might as well show you. Yeah, that's its line section there. It has 3 different taps. So those are your taps there. So it gives you 3 different voltages or wattages going up to 2500 RMS. Alright. It's warmed up, I guess. Yeah, yeah. Let's turn the high voltage on, that might help. Boy, that blower fan's really blowing. Good. 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 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. Bye. kick away a little harder. And so getting about 1150 out of it. Which you think you get a little more. 2400 volts. At the meters to be believed. All right. So we're going to have to set up our input meter next and measure our input tune. So let's take a standby and do that. Alright. So we got our input standing wave meter hooked up now. That's why I didn't have it hooked up before, but it's hooked up now. So we're going to want to measure the input standing wave. Well, that blower fan really is crazy. Yeah. And then I need to play some elevator music while we wait for this to warm up. Okay, high voltage is on. Audio. Yeah, we're like about a 1-3. Audio. And we're getting 1200 watts out of it. 15.4 audio. Swing under 1200. Now supposedly the mod's bad. Let's see if we can fix that. Talk down over there. Audio. Turn the volume on. block top. Audio, 1 2 1 2. Audio. Yeah, the audio sounds the same barefooted in the power on. Yeah. Kind of like to see it put out a little more power though. It's only doing like 1200. Yeah, well, probably do a little more work to it, but input tune is good. 1200 watts output, basically with a stock CB. That's pretty good. All right. Well, this might be it for the Skinny Boy project. We'll see if we have any more problems arise. If not, yeah, we're done. Thanks for watching my videos. Appreciate it. Everybody have a good day. Psychotech Labs, everyone. Where the psychos go. Alright. So, set a CB up over here using the monitor. That walkie-talkie's on. I think that's crap.
Yeah, 1 2.
High voltage.
Audio 1 2. Yes, that audio is distorted. Listen to that. Because we gotta fix that. That's terrible.
Yep, that's all garbly, and that was the complaint. So, I think we're just going to end up damn near building this thing. We've already been through it, did a bunch of stuff. I think I'm just going to kind of start over with it, I guess. There's been so much stuff wrong with this amp. It just never ends. So, yeah. I mean, this amp basically didn't put out power, and somebody put these resistors in the biasing circuit, and you needed at least 300 volts on the biasing circuit to make the tubes work. You know, there really wasn't any voltage, so the voltage that goes into it was actually you know, the input of the dropping resistors they put in was actually the correct voltage. So yeah, I went ahead and removed those, and bam, started putting out power and working, and everything looked good. So I gave it back to him and he took it home, and he was using it, and people said he sounded garbly, and so he brought it back. And there were some people that said they noticed in the previous video that it didn't have a filament choke. Well, this isn't pumping these RF signal into the filaments of the tubes, so it doesn't need a filament choke. I'll have to go all through the way the tubes are wired. No schematics on it, so what I got to do is hand trace everything out, basically kind of map out my own schematic, and then we'll rebuild it and make it right. So the party is just getting started on the Skinny Boy. we'll be back tomorrow. It's getting late, getting damn close to beer 30. So we'll be back after these brief messages from sponsors we don't even have. Okay. So yeah, I was reviewing some of the video clips that I've done so far, and yeah, I want to correct a mistake that I made. Okay, this isn't cathode driven, it's grid driven. So yeah, everything's grounded pretty much. So you have the cathode is grounded. Here you have pin 1, and pin 1 is your screen voltage. Okay, and then this goes into the other grid, and that's your RF in. So you got your RF going through this little ballon here, and then it goes up to this variable power knob, and then back into the input of that grid there. So well, that's a lot of solder, eh? That's typical from what we've seen in this whole build. That didn't look like it's soldered very damn good. So this is your biasing voltage right here. This is for your screen voltage right there. They're not using a full wave rectifier. So can't really tell how old those caps are. And really you only need one of those caps. You're not supposed to have that much voltage there. So we get to actually run this thing and look for any kind of ripple current with the, we'll use our voltmeter here, and we'll put it on AC. We'll start out on DC, and we'll see what we got for voltage going to the screens, and then we'll go to AC current and see if we got any kind of ripple current going in there, because it'll show up on the AC side usually if it's dirty enough. Yeah, well, let's go ahead and rig up for some dangerous tests, shall we? We'll be back. Okay. So we're going to turn this thing on. We actually have a switch to turn the high voltage on. We're going to leave that switch off. From the looks of it, I'll be able to step on the pedal, and yeah, we're going to go ahead and hook up our coax, because that's got our first ground going through it. Grounded. So we're not going to run any RF through it. Let's see what this does. No, can't do it. But the keying voltage, you know, for the relay is apparently tied into the high voltage switch. Damn. Well, I got no choice. I've got to take the measurements, so dear God, please keep me safe. Oh no, we got it. Screen voltage is too low for some reason. Yeah. Yeah, we're gonna let that sit for a while. So we got some resistors in the circuit going to ground, which is going to pull down the voltage. So I'm gonna need to get in here. First, I'm gonna unplug it. Yeah, I gotta unhook that wire right there. So let's get the soldering iron set up. Unhook that wire and see what it is when the resistors aren't drawing some of the load to ground. Because yeah, screen voltage is not acting right at all. So let's go through the screen voltage, get it all redone. Okay, so I'm going to go through that whole circuit. So I'm going to go ahead and take a pause for the cause on the camera, and I got some tracing to do. Well, I'm going to go double check and do my homework. Yeah, that's I swear the screen voltage needed to be around 300, and we're not there. Not even close. We're a little over 100. and that's not right. Boy, look at some of the solder connections. Look at that. Anyway, I'm gonna go do my homework real quick. You'll find me some schematics and double check. I'll be right back. Okay. So yeah, see, this shows 350 volts, positive 350 volts. That's DC for the screen. Okay, minus 55 volts on the biasing for the other grid. That's the grid that the input of the RF goes into. So let's go back and double test that one more time and check our voltages again. Okay. We're going to measure the biasing voltage first. Negative 38. Close, but definitely a little low. Now we're going to test the screen. Yep. Houston, we have a problem. 168 volts. I'm not sure what in the hell happened, but I went back and looked at the original video that I did, and I was getting the 300 volts I needed at that time. I guess what we're gonna do is rebuild the filtering stage here. I'm gonna go with a full wave rectifier instead of this. So let's go with a full wave rectifier. Let's put in some new caps. Let's just start over with that, and then see what we're getting for voltage. So yeah, let's get that done. Okay. So we measure our ohms here, and this resistor is 15K. I'm not sure what this one is, but when you strap a resistor across another resistor, it lowers the ohms. I'm showing 10K for the total value. Pretty much all the schematics that you find online show this is supposed to be 47K. Now we got 264 volts here, which isn't right, but yeah, we're gonna fix that. I think if we make a full wave rectifier, we'll have more voltage. But first, let's put a 47K resistor in line, and then flip it over and give it a test run, see how many watts we're putting out. Starting to get pretty late. Dinner time and beer 30 are coming up real quick, so alright. trying to get that unsoldered isn't working out too good. There we go. Good. This guy's soldering technique, did I mention, sucks, whoever did this. Look at that floating around in there. Alrighty. So they called for like I think it was a 3-watt resistor. I'm not really sure on this. This might just be a 2. Worst thing that could happen is it fries the resistor. No big deal, we got more. So yeah, we won't panic if it does. It's not gonna hurt anything if it does. If it fries, it'll just open up and not let any voltage pass. Tap that sucker together. And this goes here. So basically, this should give me more screen voltage. And that should actually make it put out more power. More power is good. And then we're going to be checking the audio also. Alright. So, before we were getting 160 some volts. Let's see what we're getting at now. Put on my gloves. Set up my voltage. So yeah, we're not putting any RF power into it. And you don't really need to warm it up either. So that's more. That's not that much more. Alright, we're gonna bag it for today. We've dorked around on this project enough. So tomorrow I'm gonna redo the rectifier circuit in there. We're gonna go with a full wave rectifier, and I think that'll bump the voltage up. And yeah, then we'll run some tests, see what the hell. Alright, that's it for today on Psychotech Labs. Stay tuned for tomorrow's episode where we rebuild that, switching it from this to a full wave rectifier circuit. And I think we're going to swap out the caps too while we're at it. And let's get that screen voltage up there where it should be. Alright, so we got the right part in there as far as the resistor that goes to ground. And what that's doing is basically just putting a steady load across the circuit, drawing a little bit of current so you don't get like a huge voltage spike, because that's not a regulated power supply by any means. Alright, we'll be back. It's another day at Psychotech Labs. Okay. Screen voltage. So yeah, we're I checked on my other video, and yes, I did get it up to 300 volts. So I don't know what's going on. We ain't got 300 volts now. We changed out a resistor, and that is right there, because they only had 10K and it was supposed to be 47K. So basically they've made a primitive voltage doubling circuit. I don't like this little flimsy choke thing. I'm thinking maybe put a Z28 choke in there. That's what I'm thinking. Alright, so we're going to have to test the input voltage of this, see what it is. We do got some other wires, like this one here. I don't know why that's spliced back into that. There again, no schematics. You get to manually trace stuff out and build your own schematics in your head or draw it out. So yeah, let's take a little look-see on the top side. Okay. Okay. Really thinking about maybe unhooking the high voltage stage. Then I can pretty much safely work on this thing. But oh well. And I really am going to rewire these switches. If you turn the high voltage on, it does nothing until this switch is on. So why not bypass the why not bypass that high voltage switch altogether. That's what I'm thinking. Bypass that altogether, and yeah. Then you flip this switch on and it would activate the high voltage and everything else. So it looks like that's what I'm going to do. Because the way it's wired is gay. I'm sorry. I said a bad word. But no, it's whack the way it's wired. So hell's bells. I want to be able to test some taps and outputs on this transit here. So that's AC and that's AC. Coming out of the transformer. Get our high voltage gloves on just to be safe. Bottom, might as well use them, right? Okay. That's off. That's 120. And our DC output. That's right, we can leave that blower fan off. $193-ish. So it's definitely not doubling the voltage. Alright. So plug that. Alright. Yeah, I gotta find these specialty leads I got somewhere. They might be in the house. Alright, I'm gonna shut the camera off and go find these specialty leads I got. I'll be back. Okay. Try a little experiment just for the hell of it. Problem is, we just don't got enough voltage coming out of that transformer to do what we need to do. Yep. 170 volts. Not enough. definitely not enough. So I'm going to go ahead and analyze the voltage doubler circuit that he had built and see if I can figure out why it's not working now. But first, we're going to need to discharge the capacitors that we just charged up. Okay, we're unplugged. My handy discharge tool. Yeah, this thing was a death trap. I took it apart, couldn't believe the 50 kilovolt rating on this. So yeah, I took it and put a big bleeder resistor in it so I can bleed stuff down slowly without going snap. Alrighty, we're gonna go ahead and test out what he's got in there. See what the heck we can get his voltage doubler, because it was putting out 300, so I know that voltage doubler circuit he had in there was working, but it ain't now. So we'll check that out and we'll be back. Okay, so a couple of capacitors, 4 diodes. So that's your basic full wave rectifier circuit. Okay, now according to the voltage doubler schematics using a full wave diode bridge, all you gotta do is solder that wire to that wire, and it becomes a voltage doubler. So let's fuse those together, and yeah, and then we'll hook the power back up, take a voltage measurement. Hopefully we won't blow the caps up or anything crazy, and we'll see if we get double the voltage. So okay, let's do the experiment. That's right, here at Psychotech Labs we do experiments. It's cool. Alright, we'll be back after some soldering. Okay, get our gloves on for safety. We're going to go ahead and bring it up on the variac. There again, for safety reasons. Okay. I've got voltage. $200. $280. Whoa! Check it out. 330-ish. Nice. Okay. So that's it for our little experiment. So we don't know what the load voltage is going to be, until we actually put it in the circuit with that 47K resistor in there. That resistor shorts at the ground, causes a load, so you don't get a big voltage spike. So that resistor, we might need to do a little tweaking there. Alright, but as you can see, you know, we're getting 170 just using it as a standard full wave rectifier bridge. We short that AC input to the rectifier bridge over to the middle of those two capacitors, and bam, we have just doubled the voltage. And so I think we're going to run with my voltage doubler circuit. What he's got in there isn't doing nothing really. So yeah, it's not good for me. All right, not really much more to say. We're going to go ahead and yeah, tidy up things in there and get to soldering. That little flimsy choke thing he's got in there, I think we're going to take that out and replace it with a Z28 or something like that. What he's got in there is pretty flimsy. The wire is really, really small, so don't need that acting as a resistor, which technically it kind of would. Alright, that's it. We're off the key temporarily. Psychotech Labs. Moving along on the project. The goal today was see at least 300 volts that we can use to power into the screen of the tubes. We've accomplished that. Let's give ourselves a pat on the back. Spear 30. We're out of here. See ya. Welcome back. Alright, so yesterday we made a basic full wave rectifier circuit, and then I showed you how to take the full wave rectifier circuit, and by adding one jumper wire we turned that into a voltage doubler. So we had 170 volts DC coming out of it. We added the jumper, and that upped our voltage to 330. That's no load voltage. So we tested these diodes in the original voltage doubler circuit, and they tested okay. So apparently one of these capacitors has failed, because we were getting over 300 volts. Now we're not. So yeah, apparently one of the capacitors failed, and that would make it not double the voltage, and would account for the audio distortion too. So let's tear out what they've got in there, throw in our voltage doubler circuit, get it wired in, then we're going to test this thing and see what it does. Stay tuned for that. We'll be back. Okay, so we got our circuit in there. We're waiting for the silicone to dry. So we got a little screwdriver jammed in there to hold it. So as soon as that stuff cures good enough, we're going to go ahead and put this thing on the variac and test the voltage going to the screen of the tubes and see what we get. So yeah, stay tuned for that. That's going to be exciting. Yeah. So yeah, let's not sit here and waste time watching the silicone to dry. Let's move on to something else. Okay, We got the variac hooked up, voltmeter hooked up, voltmeter set to DC. Let's run some power in it. See what it does. Oh wait, we'll turn that switch on. We're pumping out the power. I route the bleeder resistors off that other unit. 120 volts on the variac, 337 on the input to the screen. So we have pure DC going to the screens, and we're at 330 volts, which is good. 330 is fine. Well, all I gotta say about that is thank you, God. Thank you, thank you. Okay, let's finish bleeding off the voltage. That's right, we gotta clip it to there. Okay. So, all that's left to do is put the bottom on and then run our RF test and see what we get. So let's take a quick pause for the cows and get that done. Get her all set up for an RF output test. Hopefully it's going to have nice clean audio and put out a goodly amount of power. We'll be back. Welcome back. Okay, so here we go. Let's warm up the tubes. Oh, let me make a correction. Huh. When I was talking about this meter earlier in the video, I called it a dosimeter. No, that's a bird watt meter. So yeah, and that's its line sections tied into its dummy load. So yeah, that's bird, not dosi. Those are dosies. But yeah, that's set it for a like an FM radio or TV station. So we got a CD on over here so we can listen to the audio.
Audio.
Get in for audio. Swinging to 16. Okay, let's put it in operate mode. Got rid of that extra switch. So we just have two switches. Operate standby, on to warm up the filament of the tubes.
Audio, and audio sounds good on the radio.
1400.
Yeah.
Good 1400.
Yeah.
1425. 15400.
Yeah.
We got 1450.
Yeah.
15.5. We're done. Thank you, God, for keeping us safe and helping to get this going. Okay. Skinny Boy has been completely rebuilt. It's working now. You can tell the audio is nice and clear on our CD we got over there to listen to it. Got rid of this extra switch, so we got power on. That warms up the filaments of the tubes. And then we get operate and standby. This one's down there. It's not gonna operate. So, yeah. On off, operate standby. We've re-engineered this whole linear pretty much. So technically it's not even a Skinny Boy anymore. It's a Psychotech Lab linear. Alright. Well, that's it for this, as far as I know. We're going to go ahead. We are going to button that up and send it back to its daddy. Oh yeah. Psychotech Labs, man. Thanks for watching my video. You all have a good day. We're out of here. See ya.